If you've solved equations, you may understand that we are trying to get t by itself. When we get to the end of this process, we will say t equals 13. So right now, t has these numbers with it in this expression. First, we subtract 150 from both sides. And those cancel each other out, so they're gone, and we just have 50t left right here. 800 minus 150 gives me 650. So now I know that 650 is equal to 50 times t. And this is really similar to that process we did on the previous page. The next step is to divide both sides by 50 to figure out that t is 13. Here the 50s cancel out because 50 over 50 is equal to 1, and 650 divided by 50 is 13. We started with an equation and we solved it. Solving involves undoing the steps. Because we are undoing, we reverse the order of operations. We haven't covered order of operations, but that is coming up next week. So I rearranged the order of the topics, and once we cover order of operations, then you'll know what I'm talking about here. Normally we would multiply first and then add, but here we undo the addition. We undo the addition and then we undo the multiplication. So don't worry if that doesn't make much sense to you right now. Let's solve the problem again to find out how many months until the balance is $1,500. That's probably going to be a long time. So to do that, just put 1,500 in this slot and then copy everything else down, and then try mimicking the process of what I did up here to solve the equation. So there's my equation. I subtracted 150 on both sides. 1350 is equal to 50 times t. And then I divide both sides. And 1350 divided by 50 gives me 27. So it will take 27 months, over 2 years. The next formula we're going to look at is one that we will see again soon. This is a compound interest formula. And this is for finding the future value of an investment. P represents what you invest right now. The 1 is 100%. The R is the interest rate written as a decimal. And this exponent t represents time in years. So if you invest $2,000 at 3% interest for 4 years, what is the future value of this investment? Copy this formula down and then plug in all of these numbers into that formula. Oh, I got mixed up. Here we are. So this is me plugging in, and notice that the 2,000 goes here, 1 gets copied down. Instead of writing 3, I write 0.03 because that's my decimal, and then that 4 is an exponent. Now I've got to evaluate this expression. So I can add 1 plus 0.03 and write 1.03. And if this is confusing, we are going to learn more about order of operations next week. So we add first, then we do 1.03 to the 4th power, and I'm going to show you 1.03 exponent 4th power is 1.1255, and I'll just stop there because there's a 0 after that. And I think I told you to keep, I did not tell you to keep 4 decimal places, but that's a reasonable amount to keep. 2 decimal places is not enough in this case. There's just something about these problems that require a little bit more accuracy for a good answer. Once I have that, I can take my answer times 2,000, and I get 2251, and 2 cents basically. So 2251, or $2,251. So it looks like you earned $251 in interest because you started with $2,000. So that's not a bad investment. That's the input version of this equation, when you're just plugging everything in and crunching out what the answer is. The next one's a little trickier. You're wanting to save up 4,000, so you're like, that's how much I need to have in 6 years. The interest rate is 3%. 6 years is your time amount, and you don't know what the starting value needs to be in order for this to happen. Put the information you know into the formula and write it here. In the next step, we'll go over how to solve for the missing quantity. So we're going to want to solve for P.